passive building is one that uses durable passive elements like a robust building enclosure and high-performance fenestration to drive annual energy use down to as low as what's possible. The design and construction of a passive house project aims to be as energy efficient as possible. And one of the interesting things about that is that when you make an extremely energy efficient building, if it's done correctly, you also make a very comfortable building. They're easier and less costly to heat and cool, and they provide for superior indoor air quality. A passive house certification is the most rigorous, high-performing energy certification that one could achieve. Different ways to achieve a passive house certification and different types of certifications. What we're doing here is the FEIS Core Prescriptive Certification. Four main areas of focus in a FEIS certification are thermal control, air control, radiation control, and moisture management. First is thermal control. That's as simple as keeping the outside out and the inside in. We do this with a robust building enclosure that has significantly more insulation than a code-compliant home would have. Thermal control is not just about adding more insulation, but it's doing it in a very intentional way and doing it continuously so that we don't have any thermal bridges or shortcuts from inside to outside that can allow for unwanted heat loss or heat gain. Controlling radiation in a passive house is critical to prevent overheating or unwanted solar heat gains. It's also critical for taking advantage of solar heat gains so that you can use your windows to obtain free heat. A code-compliant window would have a U value of around 0.3, which is roughly an R3 window. The windows we're using here have a U value of 0.17, which is more like an R5.8. So significantly better thermal insulation than a code-compliant window. The other thing about these windows is they're a casement function rather than a sliding double-hung function. And that really is important for air tightness, to have that full contact, four-sided seal, kind of like a refrigerator door, rather than a sliding seal, which over time will deteriorate and become less airtight. Because we've created a robust, highly insulated building enclosure, we can use mechanical systems for heating and cooling that are smaller in capacity than what a normal home might use, but they have a lot of ductwork associated with them. So on this project, we used open web floor trusses between the first and second floor to allow for the addition of ventilation, supply, and return ductwork. We pay a lot of attention to moisture management, both during construction and after, to ensure that we're keeping our buildings dry. So on the outside, we have a sheathing with integrated water resistive barrier, and we paid a lot of attention to flashing and counter flashing and sealing of penetrations and window and door openings. One thing you'll find with a passive house is that it retains heat incredibly well, as it should. It also retains moisture that comes from just daily life. So to control that latent load or the heat load associated with moisture, we've added supplemental dedicated dehumidification with an in-wall dehumidifier that will keep our interior relative humidity at no more than 55% all year round. I'd go so far as to say that air tightness is really the most impactful lever that we have to pull to affect how well a building performs. We spent a lot of time and effort before the floor slab was poured. We laid down a 15 mil polyethylene air and vapor barrier and took a lot of care to tape every seam between sheets, every penetration where a pipe came up through the floor, every foundation anchor bolt, and every corner where the polyethylene sheathing came together. On the above grade walls, we relied on taping the zip sheathing to be our air barrier. And it was really important that we connected our work under slab to the above grade walls, taping that polyethylene to the zip sheathing at the sill, and then wrapping a piece of zip in at the top of the wall to connect to a layer of sheathing on the underside of the roof trusses, which is something that you don't often see in code-compliant construction. We seek to eliminate uncontrolled air infiltration and exfiltration across the building envelope, while at the same time very intentionally bringing in air from a controlled source and exhausting stale air from inside of the home. Passive house projects use continuous mechanical ventilation with heat recovery. Here we're doing that with a machine called an ERV, or energy or enthalpic recovery ventilator, that brings in a calculated volume of air 24/7 while simultaneously exhausting an equal volume of air. Those two streams of air pass by one another, but they never touch. The heat exchanger will temper the incoming stream with heat energy from the outgoing stream. So on a cold winter day, we might be bringing in 32-degree outside air and exhausting 68-degree inside air, but we're taking heat out of that inside air and putting it into the cold air coming in, so that we're not just dumping 32-degree outside air onto our occupants. A key component of a FEIS project is on-site QA and QC to ensure that all of the work at the design phase is accurately and correctly implemented in construction. A code-compliant project would require you to test duct air tightness in your mechanical system, for example. And that's one of the things that we're doing here as well. But with the Energy Star certification and Zero Energy Ready Homes certifications that are nested within FEIS, we have the additional ResNet QA/QC protocols and processes that really ensure that these systems are properly designed and sized for the loads that are in this building. We test ventilation rates and ensure that that equipment is commissioned and functioning as intended and as designed. We always do midpoint testing to identify any of those trouble areas, because there's nothing worse than trying to chase air leaks that are behind insulation and drywall and in a finished space. You just don't have the ability to make that building as tight as you do when it's wide open at the end of the rough-in stage. These homes are all electric and use highly efficient heat pump technology for heating, cooling, domestic hot water, and even clothes drying. Our early energy modeling of this project predicts that we'll use about 40% less energy than a code-compliant version of these homes. A lot of times project teams are intimidated by a passive house project, and they think that it's going to take a lot of new materials and things that they can't get locally and things that they've never done before. We've worked really hard on this project to demonstrate that you can build a passive house with readily available building products and just slightly modified means and methods from what you're accustomed to. The distance between business as usual and high performance construction might not be as broad as you think it is. Our hope is that this first passive house in Delaware can serve as a teaching tool and an example for other builders and developers who want to improve their practice and build high performing buildings.